Hey there everyone, welcome back to my YouTube channel. So guys, this is video 4 of our ML playlist, and in this particular video we will be discussing about feature engineering in ML. So these are some of the basic feature engineering techniques you should know, and from next video we will be doing the coding part. So first let us discuss about some of the basic feature engineering techniques in this particular video. Feature engineering is one of the most important and challenging aspect of machine learning. So in this particular process, we will be extracting the data and transforming and creating the new features from the raw data which we have available. Why you should mainly perform feature engineering to your data? Like for example, you have a data and that particular data is having so many null values, like so many of the null values and incorrect values which is not required for your data. If you directly feed that particular data to the machine learning model without any without any feature engineering or without any treating of the null values and outliers, it will perform very bad and the model accuracy will be very low and it will give you all the wrong predictions. Because of that, what we'll be doing, we will be treating the null values and we'll be checking the data properly and analyzing it. Based on that, we'll be finding the target variable and we'll be using that particular model. So for that, we mainly use feature engineering, which plays an important role for us. So feature engineering requires a combination of domain knowledge, creativity and data analysis skills. Like if you know the analysis of the data, then only right you can understand. You have to understand the correlation between two columns, why you have to use, and sometimes even the feature engineering method, when you're using the model, might show you some values which might be required to you, but it might drop those values. So at that particular point of time, you should have that particular domain knowledge and you should decide whether that particular features are important to you, or you should drop it. It should be purely depending on you, like how you are going to create that particular model. Okay, so you are understanding my point. It's all about getting the patterns and the relationship between the data. We'll be finding out the patterns and relationship between the data and we'll be using that for our further use case. So in this article, you will be having the introduction to these particular techniques and whatever challenges you will be having in feature engineering, and some of the important aspects you should know about feature engineering will be discussing in this particular video, and you can have a look on this article parallelly. And my previous articles you can have a look here, so I have mentioned all those links also here, you can have a look on that. And finally, if you have any core any queries related to these particular topics, or if you want some information from me while I'm explaining, you felt that I should know about this a bit more, you can mail your queries to this particular mail ID, and if it is a valid query, you will get a mail back. And if it is an important query like everyone should know, then we'll make a separate video on that. So you can use this particular mail ID to mail those particular queries. So firstly, what is feature engineering? Feature engineering is the process of transforming raw data into features that can be used as an input to your machine learning model. So as I told you all earlier, it's nothing but transforming the raw data, and we'll be finding out the patterns and relations between those data and taking or else extracting the important features from that. Okay, so and based on that, we'll be finding which is our target variable or else our output variable, and which are the input variables which are not required, we'll be dropping that. So there are some of the basic feature engineering techniques which you should know. So effective feature engineering can improve model performance in several ways, like it can reduce the dimensionality of the data and remove noise or irrelevant features, which can help the model focus on the most important significance. It is nothing but, so for example, you have 100 columns in your data, okay, but your data, whatever it is there, in that you only require like 5 to 10 columns, you don't require left out data. So simply without training without removing those columns, if we directly train the model, there will be a huge time complexity, the model training will be high, and even if you are using some resources, then the resource usage also will be high. So for that, what we will be doing, whatever columns we require based on our model and whatever features we want, we'll be keeping only them. Unwanted features will be removing in this particular feature engineering technique, or else in this particular step, when we are using feature engineering, we have to remove all those columns. So for example, ID is a continuous feature. When you are creating a model, why you require that ID? It is just for your reference to know where it is running, but why you require ID? At that particular point, we don't require the ID column. We can drop the ID column. I'm just telling you all the example. We'll be performing a practical implementation on this. Don't worry, just have a look on this. Okay. After this, it can create new features that are more predictive and informative than the original features, such as derived features or intersection terms or embeddings. Like for example, in your old features there are many null values, and from that particular features, let's take an example of a date or else. So if you see in some columns what happened, like date, month, year, everything is written in one column only, like date slash month slash and year. Like for example, here I'll show you. So for example, this is the date they have given. So now what you can do from this, you can extract the features, like you can separate the year. This is a month, you can separate this as a month and this as a date separately. So then what happens when you have this separately date, month, year. So based on the month also you can like get the data, like whatever data you're having. Based on month also you can make analysis, like whether in this particular month how many sales I was having. And if you have 4 to 5 years of data, then you can even make analysis based on years also, like every year how much sales I'm getting more and how much sales I'm getting less. So you can have a look on that. It will be explanation in very detail. Finally, it can improve the representation of the data and make it more suitable for the modeling tasks such as scaling, encoding, and transformation of features. This feature scaling, encoding, everything will be in the next video, and it will be definitely practical. We'll be doing practical in that particular video. I'll be taking a dataset implementing in front of you all, so you can have a look on that. There are several challenges involved in feature engineering that can make the process difficult and time consuming. Some of these features include dealing with missing data. As I told you all, there will be some missing data like NaN values which you have to remove, and if you don't remove that, then definitely the model performance will be bad. So these are some of the common challenges which are included and which you need to definitely do in your feature engineering time. Dealing with noisy features, like noisy features that contain irrelevant or misleading information, you have to remove that also. So if you don't remove that, then the model performance will be bad. So you have to deal with that and you have to remove that also. And irrelevant features, some of the features which are not even required, like or even the columns which are not required to us, I told you all right, we don't need that. We can remove those columns or drop those columns. So this is another challenge. Three challenges are discussed. Then after that, choosing the right feature representation. So from that we have to choose the right feature, and even we have to extract feature if we require at some times. I told you all right, like the date for example. You have to remove that, and you can perform better analysis if you have like that separately the date. Overfitting and underfitting. Sometimes what happens, the model will be having so much of data where some data will be very important to us, some data will be very like far features, or else you can say some of the features are very rarely used. Those kind of features we don't require. Then if we have that features, the model will perform overfitting. So there you can use statistical method like IQR method or Z-score method, and you can remove the, I mean, you can treat the data to certain point we want. So that based on that particular certain data, only the model can train and perform well, and it does not lead to overfitting or underfitting. Dealing pre-processing techniques. So pre-processing data is an essential step for performing feature engineering encoding. It is helpful in cleaning and preparing the data for further analysis. So as I told you all the pre-processing techniques, you know, right? Only them. Data cleaning, normalization, removing outliers, everything. So when it comes to feature extraction is an essential part in machine learning. It extracts the new and relevant features. This is nothing but the same like this date which I have told, right? This is, you can take an example. Feature extraction means you have to keep this date example in your mind. You have to extract the information from a column and you have to make that as a new column, or else a new column where you can use those features. So dimensionality reduction techniques like PCA can be used to extract the new features. About PCA, it is an advanced level. You can learn that slowly. And feature selection techniques, this is also same. Like normally when it comes to this, just remember in feature extraction, removing the null values and treating the noise data, and the data which you don't require, dropping those columns, only taking the important features. Okay, and after this you have removing the outliers. Like there are some outliers, or else you can say like because of which it will perform overfitting or underfitting, so you'll be removing that. And finally you will be normalizing the data, and you will be performing the task. That's all. So let me like check, I have a code, I guess. Let me perform a practical code for this particular video also. Let me open my Google Colab. You can have a look on this article. I'll be updating this particular article in this video description. Before that, how feature engineering differ for different types of machine learning models. This is very important. So feature engineering, you know, right, in machine learning you have classification, regression, clustering. So in this particular three different techniques, there are different three different things you have to use, or else three different feature engineering methods you have to use. For example, in regression model, the goal is to predict the continuous numerical value. So regression means continuous data. So the goal is to predict the continuous numerical value. So feature engineering for regression model involves like selecting relevant input features, transforming the variables to ensure that it meets the assumptions in linearity and normality. It's nothing but you should make sure that the model is linearly available, or else if it is not linear, then the model complexity might be high and performance also decreases. When it comes to this classification models, and even in regression, right, you have to deal with multi-collinearity and interaction between variables. Like there will be collinearity between the two or three features, which might lead to the drop down of accuracy. That also you have to treat. You have to make sure that also. Classification model. Classification model aims to assign a label or category to a given data point. It is nothing but, see, machine learning cannot understand the English alphabets or the words or sentences which we give. So we have to again encode that and convert into numbers, like in zeros and ones. But when it comes to classification, it's nothing but categorical, like yes or no. And if there are two to three, four features, maximum three or four features will be where you will be having like yes or no, like 0, 1, 2, 3 you will be having. Only like for example, take an experience or experience, take a column as experience. So there, if the person has mentioned everything in English words like ONE 1, 2, 3, 4. English, this one machine learning cannot understand that English. That time we have to encode that again. When we encode that, ONE 1 will become 1, numerical value 1, and numerical value 2, 3, 4, 5. So we are checking only till experience of 5. That time whatever data you have even 1,000 columns also, everything will be in between 5 features only. These 5 features which we have. You are getting my point? Clustering models. Clustering models aim to group similar data points together based on their similarity. Like feature engineering for clustering models involves selecting relevant input variables, transforming those variables to meet the assumptions such as scaling and distribution. So normally what happens in regression and in classification, you will be having the target variable. What is your target? You will be having that, and you will be just training with the input features, and you will be giving it for the target, training with the target and transforming and performing predictions. But when it comes to the clustering models, right, you will be not having any input features. You have to find out the, sorry, you will be not having any output features. You have to find out the output features based on the input features which you have. You have to find the similarities, and you have to take out the output feature. That is the main task of clustering models. You are getting my point? So guys, that's all. In this particular article I have showed all this, and let's try to perform a practical code I have, I guess. Let me perform that in front of you all once. So guys, I have this particular data to handle the outliers or else the code. Okay, so we'll be using that. Let me make this a bit more detailed for you all. So each step will be easy for you all to understand. So only I have written even the hash and the comments also, like, so that you don't feel any difficulty in between. Mhm. So the first step will be to import the necessary libraries. So I have imported NumPy for checking the datas and performing them. And I have imported this one from sklearn.dataset import make regression. So we'll be dealing with the regression data here. From sklearn.linear model import linear regression. I have imported linear regression. Okay. And train test split and MSE mean square error for calculating the metrics. Okay. So first importing is done. Now we are generating the synthetic data here. So X and Y column is having the synthetic data. Let me show you all that. So X, let me run X. Okay, capital X. So this is a regression data, right? So I have just generated it randomly. You can see these all are the features which I have. You have between like 1, -1, +4, 9, everything like these are like synthetic data which is randomly created. You can see there are many synthetic data. Now what we are doing, introducing outliers to the target variable. So I'm doing here, I'm wantedly introducing target variable in the target variable y outliers. So I'll be running this code for that. Now it will be generating the outliers here. Again, now what we'll be doing, we'll be performing the train test split of the data. X train, Y train. So we have made the train test split. You can have a look here. Train dot shape. So I have total 800 rows and one column. I told you all right, I have just generated a synthetic data here. Now when it comes to handling outliers in the target variable y, we will be using IQR. So we already introduced the outliers here. So now what is our target? To handle the outliers. So Q1 is equals to NP dot percentile, Y train is equals to 25 percentile, 25th percentile, and Q3 is equals to 75th percentile, Y train comma 75th percentile. So what is the formula to calculate IQR is Q3 minus Q1. So we will be using Q3 minus Q1 to calculate the uh, outlier percentile. So lower bound is equals to Q1 minus 1.5 into IQR. Upper bound is equals to Q3 plus 1.5 into IQR. For this, right, you can just search for IQR documentation. You will be finding many documentations here. What is interquartile range? So you can see here this graph, if you see, you will get it. So 25th percentile is this one, and Q4 25th percentile is this one. So Q1, Q2, Q3. You are getting my point. Q1, this is my 25th percentile. This is my 75th percentile. This is my 50th percentile, which is nothing but median. Here also, this is a box plot. So this all will be discussing further when we are doing our more, we need to learn like encoding and all, we need to learn some more concepts left out. So once we are done with those basic concepts, then we will be starting with the projects. We will be doing the projects in detail where you will be understanding all the steps at a time. Don't worry about the coding. Now just try to understand the concepts by seeing the articles and by seeing this particular video. So I told you, right, box plot you can see here. So this is my box plot. So this is my 25th percentile, my 50th percentile, and my 75th percentile. So here you have the IQR formula. You can see here which formula I was telling you all. You can have a look on these kind of articles. It will be very helpful for you all. And after this, what we'll be doing, so let us run this now. So what we are doing here, outlier indices. So np.where, we are using np.where method, where y train is less than lower bound. If y train is less than lower bound, and or y train is greater than lower bound, it means that check whether y train is less than lower bound or y train is greater than lower bound. Then clean indices, np.where y train is greater than or equal to lower bound and y train is less than or equal to lower bound. We are writing this particular function. We are just telling if y train is less than lower bound or y train is greater than lower bound, consider that as a outlier. And clean indices, if y train is less than or equal to lower bound, y train is greater than or equal to lower bound and less than or equal to upper bound, then consider that they are clean indices. That means that they are the clean data. Now what we will be doing, xtrain dot no outliers is equals to xtrain clean indices, and we are storing them again. Xtrain dot ytrain dot no outliers and clean indices, we are creating this at here. Now what we are doing, without outliers, model is equals to, we are calling linear regression here. Now we are saving that in a model variable, model dot fit xtrain ytrain. So before that, like after completing this, right, we have stored here, right, xtrain no outliers dot shape. Let me run this. You can see here 785 and we have one column. This means, like previously, if you see, we have 800. Here you can see we have 800 rows and one column. Here we have 785. It means 25% of the data was the outlier. Sorry, not 25%, 25 rows. 85, okay, sorry, 15 rows were outliers. So we just removed that particular 15 rows from X train, not no outliers. When it comes to Y train, same. If the data is not in proper also, it will lead to mismatch of the data and it will not perform well. So it will be same only, obviously, the columns. Now what we are doing, so without outliers we have here, so we are performing linear regression. We are fitting that with X train and Y train. And then we have saved the mean square error without outliers, we have mentioned here. So for that we are checking here. Let us check this also. So you can see here MSC without outliers is 431. And without outliers, so model outlier handle linear regression. So we have done all this. And finally we'll be printing the MSC. We are checking the mean square error. So I told you all, right, so only we have just removed the 15 rows, right, of the outliers. So what it has happened, you don't see much improvement. So MSC without outlier handling, you will see 431, and with outlier handling you are seeing 432. Here only 15 rows, right? So we are not seeing much impact. When we are training with the large data sets, when you have 10,000 columns, 20,000 columns, you will definitely see the improvement. This is just an example from my side. So guys, I'll be attaching this particular collab file also for you all. You can have a look on that. That's all for today's video. Do like, share and subscribe the channel. Thank you all. Bye bye.